Okay, class, so we're going to be going through lesson 2, area and perimeter of 2D composite shapes today. So just as a warm-up, let's figure out what are the shapes in the diagram below. So I'm just going to go in here and I'm going to try to figure out what types of different shapes there are. So right off the bat, I know that there's a triangle here, right? So I'm going to label that in the dark blue. So I know that there seems to be this triangle here, right? Then I'm going to go see, oh, look, there seems to be this rectangle here as well, right? So that's just in the purple. And then right underneath that rectangle in the green, there's a semicircle over there, right? And then if we look closely over here, there's also another triangle like that, right? We can even make the triangle a little bit bigger. We can make it like that. And then last but not least, we have this orange little square down here as well. Right, so there's quite a few shapes in this diagram. So what we're going to be talking about today is determining area and perimeter of composite shapes. Before we do that, we just need to figure out what a composite shape is. So this is an example, a really good example of a composite shape, right? It's a shape or a figure that consists of 2 or more geometric shapes. So in this situation, we had 1, 2, 3, 4, 5 different shapes that made up that one shape, right? So when we're determining the perimeter in the area of a composite shape, there's a few steps and I've outlined them here. So the first step to determining the perimeter is trace the outside of the shape, right? So if we had gone here and we had just traced the outline of this shape, right? Calculate any missing measurements. So we're just looking at what's on the outside, right? And then once you figure out any missing measurements, just add up all the side lengths and that'll give us a perimeter. So perimeter is pretty easy to find. Area is when it starts to become a little bit more complicated because area in itself is a little bit more complicated. So remember how up here we divided this into all these different shapes, right? That's what you're going to do. You're going to divide the figure into regular shapes that we have formulas for. Again, those formulas are on D2L, and if you go into D2L, under your first lesson it says formula sheet. Over there, click on the formula sheet and you'll find it. Okay? So divide the figures into regular shapes, then identify the formulas as needed. Then you're just going to go in and you're going to measure, figure out any measurements, like if you need any side lengths, right? And then calculate the areas and add them together. Or say you have one of those shapes where you're like, find the area of the shaded rectangle and like get rid of the circle, right? In that situation, you'd have to subtract. So we've kind of done something similar like this. If you go back and you think about Unit 2, we kind of did that with the area of the shaded squares and the shaded rectangles. The one thing about these ones is I'm going to say it's a lot of, like I know I've given you steps, but a lot of it is just logic, right? So I want you to use those thinking and inquiry skills that we've been working on to determine how to find the area and perimeter of a composite shape. So let's just go here and say, okay, it says to find the perimeter and the area. So let's go find the perimeter first. We know that this is 22, right? So I can just go in and I can already say perimeter is just going to equal all sides added together, right? So we know that perimeter is just going to equal all sides added together. So we know perimeter is going to equal the 22 that we just found, plus we have 15 centimeters here, right? So I'm going to go in, I'm going to say, all right, plus 15, plus we have 15 centimeters here, right? Let's say 15 plus, and then at the bottom over here, I'm just going to put that in maybe a yellow. We have 3 centimeters down here, right? We're missing 1. We don't know what this is, right? So we don't know. I'm just going to change that color to maybe a red, right? We don't know what this is. So this is kind of a question mark. And we don't know what this is right here. This is kind of a question mark. So if we think about it, we do know what this top length is. So we do know that if I had put all of this together, this entire thing, I'm going to put it in the red so that we're kind of in a consistent color. This entire thing is 15. Now, if I want to find out how much the red portion is, I know that the bottom was 3, right? So to find the red portion, I'm just going to do 15 minus 3, right? Because that's the part that's cut off, that we're missing that green part. So 15 minus 3 is going to give me 12, right? So I'm going to say plus 12. Now, I want to do the same thing, something similar for the green side, right? So I'm just going to go here, I'm going to erase this. So let's work with this green side here, right? I know that this entire length is 22, right? I just want to know how much this tiny length is. So I know this entire length is 22, right? But I know from top of here to here is the same as here, so that's probably 15 centimeters. So if I know that everything is 22 and then that top part is 15, I can find out the bottom part and say, okay, 22 minus 15 is what? 22 minus 15 is going to give me 7. So I know that this green part is just plus 7. So see how you can use all the information from the different shapes to find out what our different side lengths are? That's what I want you to do. Again, it's a lot of problem solving, so like I can show it to you, but a lot of it is going to be you have to think, all right, logically you have to think about how can I find that side. But now I have all of these. I have 22 plus 15 plus 15 plus 3 plus 12 plus 7, right? And my entire perimeter is going to be equal to 74. And we know it's centimeters, so we're going to say it's 74 centimeters. And that's how you find perimeter. Okay, that's pretty easy. Like I said, it seems to be the tricky part always is finding the area. So what we're going to do is we're going to actually look at this and we're going to say, all right, can we split this up into two different parts? Kind of. We can split it up into this, right? And then we can split it up into this blue rectangle down here. We know that this blue rectangle, the side is 7 centimeters. We know that the top is 15, right? And then when we go back and we look at our formula sheet, if we go back and we look at our formula sheet, it tells us we have two rectangles. The area of a rectangle is equal to length times width. So let's find the area. We'll make this area 1, and we'll make this area 2. So let's find the area of the first rectangle. I know that my width is 15 and my length is 15. So I'm going to say length times width equals 15 times 15, right? And that's going to give me 225 centimeters squared is the area of my first rectangle, right? So this is 225 centimeters squared, right? The reason I use the 15 and the 15 is because we're not actually using this whole 22 centimeters. We're only using the 15 part of it because this triangle, this rectangle ends here, right? So we are missing this portion. This portion we know is 7 centimeters because we found it the first time we did our perimeter. Now, let's find the area of that tiny box at the bottom. Let's find the area of 2. So I have length times width, and I know it's going to be 7, and I know the bottom part is 3, so it's going to be 21 centimeters squared. So it's 21 centimeters squared. Now, if I want to find out how much it both is, I know I need to take this and add it to this, right? So I'm going to say area total is equal to A1 plus A2. So area total is equal to my 225 centimeters squared plus my 21 centimeters squared. And then 225 plus 21, just going to throw that into my calculator, right, is going to give me 246 centimeters squared. So I know that the total area of the shape is 246 centimeters squared, and which is what we did. So we divided the figure up into regular shapes. We did that, right? We identified the formulas as needed. So this was step 1. This is step 2, right? We calculated the missing measurements, calculated the areas, and then we added them together. Okay, so that's that. So you either need to add them together, and in this situation, we needed to add them together. In this situation, right, you have this box, but you're missing this top portion of it. So are you going to add or are you going to subtract? You're going to subtract because you're actually missing this portion. It's not filled in, right? So what you want to do is you want to go back and be like, all right, I want to subtract this semicircle over here. I want to subtract the semicircle. But in order to subtract that semicircle, we need to find out what its area and perimeter are. Okay? So first things first, let's do area and perimeter. We need to know we have the 20 over here, we have the 17 over here, and we have the 20 over here. But we need to know what is this circular, what's that circle? What's that? Right? What's the perimeter of that circle? So we're going to say perimeter is equal to 20 plus 20 plus 17. 20 plus 20 plus 17 plus the unknown circle that we don't know. If we wanted to find that unknown circle, we know that it's a circle. So I'm going to go back and I'm going to look at my formula sheet that I have open beside me. And I know that the circumference or the perimeter of a circle is equal to C equals 2 pi r. Right? So I know it equals C equals 2 pi r. So C equals 2 pi r, or C equals pi times diameter. I know that this top portion is 17. That's also the diameter of this circle. That's the space across half of it. So I know that this also equals diameter. So I can go back here and I'll say, okay, so I have C equals pi times diameter, which was 17, right? So I have 17 times pi. I'm just going to put that into a calculator, and I'm left with C equals 53.4 centimeters. That's the circumference of the whole circle. So if this was like an entire circle, that would be the circumference of the whole circle. I only have half the circle. So if I want to know what half the circle is, I'm just going to take whatever the circumference is and divide it by 2. Right? And this is what I'm saying. It takes a little bit of thinking. Divide by 2, and divide that by 2, and it's going to be 26.7 centimeters, right? Meters, sorry. So now my perimeter is going to equal whatever this is plus 26.7. So I'm going to have 20 plus 20 plus 17 plus 26.7, and that's going to give me 83.7 meters, right? Because now I have this 17, this 20 plus 20 plus this circle over here represents my 26.7 meters. Okay, I'm just going to go write that in. Therefore, perimeter is, and it says to round to the nearest tenth, which is 7. Okay, so I have that. Now, let's go back to this and say, all right, area. So my area total, right, is going to be, we have this rectangle, right? We have this rectangle. If we see it like this, we see it as a rectangle with this chunk taken out. So let's make this chunk orange, right? So we have our area of the rectangle minus, so we're going to take our area of the rectangle minus area of the semicircle, right? If we want to find the area of a semicircle, it's just the area of a circle divided by 2, right? So let's just do that. So let's figure out it separately. Let's figure out the area of the rectangle. So I know that my area of the rectangle is going to be length times width, so it's going to be 17 times 20. length times width equals 17 times 20, which is going to give me about 340 meters. That's easy. We know that. Let's find the area of the semicircle. So we know that the area of the semicircle is equal to area of a circle divided by 2. Okay, so I'm going to do this step by step. You can do it all in one step. It's completely up to you. So I'm going to go back here and I'm going to look at, all right, my area of a circle is equal to, pi r squared, and then I'm just going to divide that by 2. Right, pi r squared is the area of a circle. I'm just plugging it into the equation. My r is equal to the diameter divided by 2. So I'm going to take 17, right? Divide that by 2. 17 divided by 2. That's going to be 8.5 squared times pi divided by 2. So I'm just going to put those numbers in. 8.5 squared gives me 72.2 times pi gives me, and I'm just going to carry this up over here, 226.98, right, divided by 2 equals 113.49, which I'm just going to say is 5, right, 5 meters squared. So that's the area of my semicircle, right? And now when I go back to my original thingy that I found, I want to find my area total. My area total is going to equal the area of my rectangle minus the area of my semicircle, right? So my area total is going to equal 340, which I took from here, meters, minus 113.5 meters. They're both meters squared, equals, I'm just going to put that into my calculator, and that's going to give me 226.5 meters squared. So I know the entire area of this composite shape is going to be 226.5 meters squared. Okay. So, like I said, as we go on, it just gets more and more complicated. Try doing example 3 and example 4 on your own. It gives us a really good understanding of what you understand. And again, like I said, this is a lot of that thinking and inquiry skills. It's using the resources you already have in order to figure out and solve a problem, right? So I want you to try doing those by yourself. And then when you get back to it, pause this video. So pause this video now, try to do it by yourself. And even if it's a little bit frustrating, I really want you to try working through it and then come back and watch the video. Okay?